All right, everybody, we're going to finish up these notes. Now, the next one we're going to do is a cube root. So we did the square root, and it's time now to do the cube root. So for cube roots, you need at least 5 points because you'll have a middle point and you'll have 2 on either side. So 5 points for cube roots if you want full credit. All right, make sure to include the middle point of cube roots is the most important. So let's make our XY chart. Now, typical x's you should pick for a cube root, you're going to refer up here. So our typical x's will be these ones. I'll just do a quick duplicate and drag that down. Yes, you will have to have these memorized. But because this has a +1 inside, I need to remember that that means left 1. So left is going to be subtracting 1 from all these values. So I can plug things in, and I can do it in my head. So that would be -9 that I'll plug in, -2, -1, 0, and 7. And now it's time to plug those numbers in. So I am going to, right here, I'll just write 1/2. I'll write it kind of small, cube root of x plus 1. Get rid of all that extra root here. And then a -4 in the back. I'm going to go ahead and duplicate that. And that's what I'll use to plug things in. We should probably mathematically be at the steps now where we can plug these in our head. If you need to use your y equals in your calculator, that's absolutely a tool that you can use. But I'm going to plug these in using the algebra skills that I have. So I'm going to put in -9, then I'll put in -2, -1, 0, and 7. All right, -9 plus 1 is -8. The cube root is -2. Times 1/2 is -1. -4 is -5. So my first point is -9 and 5. So I'm going to go left 9 and up 5. Let's see. Looks like I'm going to have to count by 2s on my x-axis just because I don't have enough space. Let's see. Make that smaller then. -2. Sometimes kids freak out when you have to count by 2s. But it's okay, you can count by 2s. So -9 and 5 is going to be 1, 2, 3, 4, 5. I'm going to skip by 1s on my y-axis. I have plenty of room to skip by 1s. All right. Oh, that should be -5, huh? My bad. -5, -5. All right, let's see. 1, 2. Oh, looks like I'll be counting by 2s. All right, well, I guess even the best of us make our own mistakes, huh? So we're going to count by 2s. -2, -4, -6. Okay, -9 and -5 is going to be right here. Now, -2, let's see. This is going to be -1, which is the cube root is -1 times 1/2 is -0.5 minus 4 is -4.5. Okay, so I'm going to go to -2. I'm going to go to -4.5. Now I'm going to plug in -1. -1 plus 1 is 0. Cube root is 0 times 1/2 is 0. Minus 4 is -4. Again, if you need to use a calculator, please do so. There's your middle point. Plugging in 0, let's see, that's going to be cube root of 1 is 1 times 1/2 is 1/2 minus 4 is -3.5. We're going to finish these videos. So over 0 and down 3.5 will be like right here. Kind of that weird little curve that happens. And plugging in 7, I get the cube root of 8, which is 2 times 1/2 is 1 minus 4 is -3. So that's going to be over to the right 7 and down 3. 2, 4, 6, 8. So let's see, there's 7 and there's -3 right here. So you can see this has been vertically compressed by a factor of 1/2. That's why it's kind of like squished together. You can see that it got moved down 3 units from the 3 in the back. There's the little S shape. And you can also see that it moved to the left 1 unit than the original. All right, now the last thing we need to do in this particular function is find the domain and range. Okay, sorry for the edit I had to take out there. We had some announcements. So the domain is all real numbers. So we'll just say x is all real numbers because it points forever left and forever right. You can write -infinity to +infinity if you prefer. The range is also y is equal to all real numbers because it does go up and down forever. Again, if you like writing this -infinity to +infinity, you may do that. All right, now we have talked about how to transform them. We have talked about domain and ranges. But now we need to go ahead and talk about how do we simplify functions so there's simplify functions when there's a number in front of x so that we can better discuss what the transformations in the graphs will look like. So we have 2 examples. We have one which is the square root, and then we're going to do one which is a cube root. Okay, square roots. Let's start here. How can you rewrite y equals the square root of 9x plus 18 so that you can graph it using its transformations? Describe the graph. Step 1, this is a square root. It's very important to recognize this. You're going to pull out a GCF or really just the coefficient of x. So we'll write y equals, but instead of leaving it as it was, you're going to pull out a 9 like this on the inside. So you divide everything by 9. So that becomes x plus 2. Now what you're going to do is you're going to take the square root of that number. So that square root of 9, because there's a multiplication symbol here, we're allowed to do that. We're allowed to write a 3 on the outside and leave x plus 2. This is the simplified form. The next thing we're going to do is describe the graph. So this plus 2 on the inside means that it's moving left 2, and this 3 in the front means it's a vertical stretch by a factor of 3. If there's more, you would have to describe it more. So this is the simplified version. These are the transformations and what the graph would look like. And again, the graph would have this arc shape, but it would be moving left 2 and it would be vertically stretched. Okay, now we're going to go ahead and do a cube root. Okay, so now we have y equals the cube root of 8x plus 32. This is a cube root. It's very important to recognize that. Pull out the coefficient of x. So we have y equals the cube root of 8. When we divide everything by 8, we get x plus 4. Now what we need to do is take, I've said, yep, take the cube root of that particular number. So the cube root of 8 is a 2. That leaves us with the cube root of x plus 4. Now we're going to describe the transformations. This 2 is a vertical stretch by a factor of 2, and this plus 4 is left 4. If there was something in the back, we could also say up, down. There is a fun fact down here. Oh, and that's how you describe the transformations by editing the equations. There is a fun fact down here if you ever want to try using your calculator. This is a word problem. If you are ever given an equation and they ask you to like evaluate for the value of y, for like this one is population, and they're asking x represents year. So let's see, this side is population, x represents what year it is. They said, what year is it 250,000 people? Well, what you can do is in your y equals on your calculator, you can put the equation. And then in y sub 2, you remember how your calculator has like a whole bunch of y equals and the y equals button? You can put 25 or 250,000. But then you're going to have to change your window so that you'll actually be able to see these two graphs because they're so high. But anyway, if you can do the buttons you hit on your calculator will be second trace, and you'll find this intersect. And if you hit enter 3 times, it will show you the intersection, and that will give you the x value for that y value that you're looking for. So in this, whoever did this one, they put it in their y equals, and they ended up getting the intersection to be at 1987. So you can see it's right there. Now you can do that by hand by like dividing each side and doing it by algebra, but it is a way to use your calculator if you'd like to. All right, main facts. You should be able to come in here and tell me the x values that you should reference. You should be able to come in here and reference all the domains and ranges, and you should be able to tell me how to simplify in order to describe the transformations.